Hello all, this is Nandini, Assistant Professor, Department of Computer Science at Dr. SNS Rajalakshmi College of Arts and Science. So in this video, we are going to discuss about the basic methods of solving problems in AI. So let's discuss. So the AI technology can be divided into 7 categories, which is according to the way to solve the problems. So that the 7 categories are detection, clustering, classification, prediction, optimization, generalization ability, and creation ability. So the detection, which is nothing but it is the process of data processing and feature extraction, which is based on the prior knowledge and analysis objectives. And the detection is also an abstract process for analyzing the objects and to extract the more critical and effective small amount of informations, so that informations could represent the whole situations. So this is how we look at the world. Our vision has focus. So this vision is focus is placed where the information collections, which is efficiency, so that efficiency is the highest one, and you do not always need to look at the whole scope or every bit of information to judge it. Our brain, which is evolved the over time to use this method, and the method most efficient way to process the information. So this is the introduction about detection. So let's discuss the example. So the best example for detection is the fault finding in the industrial scenario. So when we want to detect a fault on an outer race of a bearing, so we need to focus on the extracting features of specific frequencies. So that can be distinguished for a normal bearings. So when analyzing the fault in an inner race, we would look at the other frequencies. So before solving a detecting problem, people need to define it by using domain knowledge at the first. So this is the example for an detection. And the second method is clustering. So clustering, it is the most common method of unsupervised learning. So the different variables, different definitions of indicators, and different number of aggregators, and the different initial conditions will affect the results of clustering. So the clustering, it is the basic common method, so which is used some tools in a large data mining. In many applications of business intelligence, the analyst use the characteristics of various dimensions in the data to aggregate the customers, then go to find the common features in each cluster, has to create more suitable and targeted business strategies. And the next method is classifications. So once the clustering process is over, then the next method is classification. So it is helping to solve the problems. If we have an existing aggregations or labels of samples, the best tool to train would be classification algorithms. So in this classifications, we can typically supervised learning and convergent clustering problems. So these two problems can take a new samples, and to finding a group, it should be to solve the problems. And the next method is prediction. So it is nothing but establishing a mapping the relationship between group of variables and the group of implicit explicit variables, or using the measurable objects to predict unmeasurable objects, and using current observations to predict the future states. So which means when we hidden the variable is discrete, our prediction is a lot like a pattern recognition and classifications. When the hidden variable is a continuous number, the prediction problem can be treated as regression. And the next one is optimization. So optimization is nothing but by adjusting the decision variables under certain some constraints. So this problem can be divided into two processes, that is mathematical modeling, and another one is mathematical solving. Mathematical modeling is nothing but it is a quantitative definition of objectives, constraints, and mapping the relationships from decision variables to objectives, because the Predictability, which is depends on what is planned and the accuracy of prediction, it is the guarantee of finding the optimal solutions. And the mathematical solving is nothing but it is a search framework, as in the process in which the decision variables which is converge gradually to the optimal objectives. So these are the two process of optimizations. Let's see the example. If we are taking a facial recognition for an example, for an these method, we can use these 5 methods of problem solving. So the process includes the face detection and calibration, face features extraction, face clustering, and facial recognitions. So these are the 5 process for these are the 5 process. We can use this process to solve the basic problems in with the help of an AI. So let's see the process of facial recognition. So first we have to find out the face detection and calibrations. So the face detection is nothing but to locate the location of the face in the picture. So this is the main important one. So this is it is called as an input. So this input of the face detection algorithm is a picture of a face, and output is one of the face frame. So these two input and output face frames are bounding some boxes on the pictures, so which shows where the algorithms believes the face to be. So generally this output face frame is an upright rectangle, but newer algorithms allows for a parallelograms or rotated rectangles. So after the location of the face is detected, the image registrations is needed to locate the coordinates of key facial features on the face. So this input of the registration algorithm is a face picture and the face frame, and the coordinates of a nose, eyes, ears, and mouth can be a output one. And the second process is face feature extractions. So the face feature extraction is nothing but it is the process of transforming a face images into a series of fixed length values. So these values are called as a face features, and the ability which the face features abilities, it have some abilities to represent the face numerically. So here the input is face image, and the coordinates of a facial features, and the output is set of values which is corresponding to the unique features of the face. So these allows data types to represent the unique face and allowing a efficient facial recognition. And the next process is face clustering. So the clustering is nothing but it is a group of faces in a set according to their identities. We can use some kind of clustering algorithms to protect the group of faces. So the facial clustering is also compares all faces in a set, so in each other, then they analyzes the similarity values, then divide the peoples that belongs to the certain categories into a cluster. So before labeling, only one group of faces belongs to the same identity and the exact identity is not known. So this is the meaning of the face clustering. And the next one is facial recognition. So here we can use an algorithm to take facial features as an input, and we can identify the corresponding identities in a database. Then we can easily finding the identity with the highest similarity. If there is no identity that has a suitable amount of similarity with the input picture and not in a library, then error is returned. So these are the 5 process of facial recognition. So this is an example for the 5 basic methods of solving a problem with the help of an AI. So we can use these 5 process, and we can easily solve the problems, that is basic problems, with the help of an AI. So this is the assessment and these are the reference. Thank you.